Welcome everybody. We're going to be starting our Unit 2, Section 3 Chem Talk. There really isn't a Section 2 for Unit 2, so we're going to hop right into Section 3. You want to have your green sheets out and open to page 5. The top should say Chemical Names and Formulas. All right, so hit the Continue button once you have that and you're ready. Let's begin. All right, so first we'll talk about cations. And these are positively charged ions. We talked before in a previous section about how ions are just elements or compounds with a charge. And if they have a positive charge, we're going to call them cations. I'm going to do something really embarrassing, so please don't share this with anybody. But the way I remember this, right, the beginning of it starts with cat. And I think cation are positive. Okay, we're never going to repeat that again. So this just means that these atoms have lost an electron. So as they lose an electron, which holds a negative charge, right, they become more positive. We've talked about this before. When atoms lose an electron, just like if you lose a negative friend in your friend group, right, you become more positive. Anions are the opposite of cations. They are negatively charged ions. So what this means is that they have gained electrons. And the way I help, the way that helps me remember that anions are negative is that there is a second N, right? So there's two N's in anions, just like negatively starts with an N. So that's how I can remember the difference between cations and anions. All right, now this is going to be a term that you must know, so I would probably put a star next to it. Polyatomic. So a polyatomic ion is composed of two or more atoms that act like one single ion with one charge. Some examples of this would be OH, which is the hydroxide ion. It has an oxygen or an oxide ion bonded to a hydrogen. Right? Or we have ammonium, which is a nitrogen and four hydrogens, right, which act together to have a positive one charge. Or nitrate, we have a nitrogen bonded with three oxygens, and that has a negative one charge as a group. And then we have sulfur bonded to four oxygens with a negative 2 charge as the group. These subscripts written down attached to, right, some of these atoms, they need to always stay with those atoms. We do not change these. What we will be changing later is going to be the charge, but we'll get to that then. All right, so cations and anions will join together to form a neutral ionic compound, and these will have a charge of 0. So our job is going to be to cancel these charges out. Right? And if we have, right, a positive ion with a positive charge and a negative ion with a negative charge, right, if we add those two together, let's say it's like a positive 2 and a negative 2, we get 0. And that's what we mean by adding them up to 0. All right, guys. At this point, you should not only have your green sheet out and open, but we're going to also need our pink ion cheat sheet that we gave you in class. All right, so the side, make sure you have the side that has the positive ions out, and also it should have the negative ions on the other side. So I'm going to teach you how to put some ionic compounds together. First step, you want to read the name of your compound. So here I have potassium chloride. Our first ion is always going to be a positive ion, and our second ion is always going to be a negative ion. It's always going to be in that order, so we always want to do positive first. So I see my first ion here is potassium. So I want to look on my pink paper for the ion potassium, and I see right here it is K with a positive 1 charge. So I can write that down in my scratch work, K with a positive 1 charge, and that's a capital K. All right, my next ion is chloride. And remember, that's a negative ion or an anion, so I want to go to the other side, find my negative ion, which is chloride, and that is Cl with a -1 charge. So we have Cl, a -1 charge. All right, this is one of them that is as easy as it gets because they both not only have a charge of 1, but they're the same. So we want the charges to be equal and opposite so they add up to 0. If we look, my charge here is a positive 1, and I have a charge of a negative 1. So if I add positive 1 plus negative 1, I know that's a horrible looking equation, but that equals 0. So that means I am good to go. I would write this, right? I only have one potassium ion needed to cancel out one chloride ion, so I just write it as KCl. No subscripts needed because I only need one of each ion. All right, let's try the next one. So I have magnesium and sulfide. So why don't you find the ions or the symbols for magnesium and sulfide? Very good. We should have Mg plus 2 and S minus 2. All right. Again, these charges are already equal and opposite. It only takes one magnesium to cancel out one sulfide, even though the charges are positive 2 and negative 2. Right? When we add these two charges together, we end up with 0. And it took one magnesium and one sulfide, so I just write it as MgS. Right? If you need to, think back to the activity we did in class with the puzzle pieces. Right? Even though my magnesium puzzle piece was larger than my potassium puzzle piece, right, so is my sulfide. Right? So it only takes one magnesium to cancel out one sulfide. And let's try another example here. Here we have iron 2, right? This Roman numeral 2 means I have a positive 2 charge of iron and carbonate. So we want to find those ions. Right? Look on your pink paper. So we end up with Fe plus 2 for iron and CO3 minus 2 for carbonate. All right, another easy one, our charges are already equal and opposite. So I don't need to add anything more. It would just be FeCO3, right? No spaces in between, right? Any letters that are capital, that when they're in their symbol, stay capitalized. And that 3, right, belongs to our carbonate ion, so it stays attached to the oxygen. All right, so when we have two ions that have equal and opposite charges, it's pretty easy. We just copy them over to the side. Now it can get a little bit more difficult. All right, so we should have turned the page to page 6 in our green sheet. I'm covering up because I had a little technical difficulties. I don't want you to see any answers ahead of time. So I'm actually going to be starting with the second one, silver sulfide. So if you could take a second, I want you to write down both of the ions, right? The ion for silver and the ion for sulfide. Good, now you can check with me. So silver has a positive 1 charge, and sulfide has a negative 2 charge. These charges are not equal and opposite. So just like we did with the puzzle pieces, we have to add whole numbers or whole ions together. So in order to cancel out the negative 2 charge of sulfide, I need to add another silver ion. Right, so now I have a positive 2 charge with my silvers and a negative 2 charge with my sulfide, giving me a total charge of 0. Now when I write this down in my formula, right, I have a silver ion and I have 2 of them, so I write a 2 subscript. All right. Now I only have 1 sulfide, so I just need to write S. No need to write a 1 next to the S. The S shows I already have 1 there. But this subscript here tells me how many ions I needed, right, to cancel the other out. Alrighty. So let's try one a little bit more difficult. Let's try barium nitrate, and I'm going to teach you something tricky here. So take a second, write down your ions. You should have written Ba plus 2 for barium and NO3, the negative 1 charge, for nitrate. All right. Hopefully you notice nitrate is a polyatomic ion, right? Because we have more than one capital letter or more than one type of atom inside this ion. In order for these charges to cancel out, I'm going to need another nitrate ion because I have a positive 2 charge for my barium and only a negative 1 charge for my nitrate. So I can write down another NO3 with a negative 1 charge. All right, so when I write my scratch work, I only have 1 barium, so I just write Ba. But when I have multiple polyatomic ions, right, see how I have 2 nitrates? I need to write this in a parentheses. So we put the ion in parentheses, and then how many of that ion I have in a subscript after it. Right, now, the reason I do this, right, if I did not have the parentheses there, it would look like BaNO32. Right? We don't have 32 oxygens, so that can't be right. Right? I can't just multiply that 2 to the 3. If I just wrote BaNO6, right, that's not the same thing because I do have the 6 oxygens I need, right, but that 2 does not distribute to the end down here. So still, again, not the correct one. When we have a polyatomic ion and we have more than one of it in order to make our ionic compound, we represent that in parentheses. All right, moving on to our third example on this page, we have iron with a positive 2 charge and phosphate. So write down your symbols. So I have Fe plus 2 and PO4 minus 3. All right, so you might remember, or you might already be thinking about the one rectangular puzzle piece you put together, which had a lot of different pieces in it. Right, so that's what we're going to be dealing with here. We have a positive 2 charge and a negative 3 charge. Right, there's no quick fix like adding one silver right down here. We're going to need to do a little bit more. And you can do this two ways. One way, you can look at our charges, the positive 2 and the negative 3, and try to identify what the least common multiple would be. And in this case, our least common multiple is 6. So we can try to get our irons to a positive 6 charge, and we can try to get our phosphates to a negative 6 charge, and that way they'll cancel out. Another way you can do this is just whichever one of the charges is lower, so this 2 is lower than the 3, just add another. Right? And that's how I'm going to do it here. So I need another iron, so we'll write that down. Right, now I have a positive 4 charge on my irons and a negative 3 charge for my phosphate, so I will add another phosphate. That gives me a negative 6 charge with my phosphates, so I need one more iron to get to my equal and opposite charge of positive 6. So I have a positive 6 net charge here for my irons, and I have a negative 6 net charge here for my phosphates. All right. When I write this into a compound, I have 1, 2, 3 irons, so I write it as Fe3. No parentheses needed here for my iron because it's a monatomic ion, right? Or it's not a polyatomic ion. There's only one element in this ion. Right? But here I have phosphate, a polyatomic ion, and I have multiples of it, so we must put it in parentheses. Right? And then I have 2 of them, so I put a 2 after the parentheses. All righty. So hopefully this gave you a little bit of confidence in writing out our ionic compounds. Please, please, please take note of when we use parentheses and when we don't. We want to use parentheses when we are using multiple polyatomic ions, right, to cancel out our charges. If it's multiple of a monatomic ion, right, you don't need them. And just like on page 5, if we only have one, like in this case carbonate, there's no need for a parentheses either, right? Because there's no number that needs to distribute through it. Okay, so only when we have multiples of our polyatomic ions.